Calculus! This is AP Calculus, lesson 9-3. Our zooming is all weird. There we go. Approximating average value. Today's date is Tuesday, February 12th, 2/12. Can you believe that we're done with our lesson after today? That's crazy.
Wait, really?
Yeah. 9-3 is the end of the lessons. And then we do 2 self-checks, a pre-test, fix-up, and test. Yeah, it's coming fast. All right, so we have more review time than the lesson time, I believe, in this lesson or this unit. All right, so let's talk about the difference between total change and average value. So we've already talked about total change before. You just take the integral of a rate and you get the total change. That change might be negative, it might be positive, but yeah, you take the integral of a rate. So what is average value? What do you think we're going to change? If I find the total change, what do I do to that to turn it into an average? Any ideas? Ideas? Going once? Going twice? It might become clear once we actually talk about what total change looks like. It's exactly what I said. So if I want to, for example, find the total change between, I don't know, time equals 1 and 7. Tell me what to write. Total change between 1 and 7.
So then 0 to 7?
1 and 7, right?
Oh, 1 7, my bad.
1 and 7 of?
R of t.
dt. And let's just make up a number. I don't know. I'm feeling like 52. Let's just assume it's 52. And this was just an assumption.
Should we do those curly things when you put equal?
Approximately equal to? No, we're just going to say it is exactly equal to. I just made that up off the top of my head. All right. I want to find the average value of R of t over the period from 1 to 7. How's that going to change?
Would it be the same thing, just putting R prime?
That's a good idea. So put in R prime, but R is already a rate. So by finding R prime, we'd be finding the acceleration, I guess. So I don't think that would be quite right. It's a good idea, though. It's really darn close to what I was going to do. In fact, yeah, it's going to be really close. So it's still going to be using total change. So I'm going to write this down, and I'm going to do something to it. Integral from 1 to 7 of R of t dt. And we know that's equal to 52. But something is going to change now. What am I going to do to this to find the average?
Maybe 10 by t?
Good idea, but not quite. Let's say this. I have 3 numbers, 1, 2, and 3. How to find the average of those 3 numbers?
Divide by 3.
Divide what by 3?
Add them together and
Add them together, then
divide by 3.
divide by 3, because 3 was how many we counted. This is what we're doing. We are counting by taking the integral. That will take the total change. But we forgot to take the average, which is doing the additional step of...
Before, right? Because you add 1 plus 7 equals 8.
Well, this integral is adding them. It's adding those infinitesimal bars, adding that bar plus that bar plus that bar. It's adding those infinite bars. That's the adding part. So we've added by taking the integral. What are we missing from our definition of average?
Divide by 6.
Divided by 6. Where did the 6 come from, Ben?
7 minus 1.
Divide by 7 minus 1. That's the only difference between total change and average value. Average value, you just divide by the total time in that interval. The total time coming from the distance between 1 and 7, which is 7 minus 1, it's 6. So
a better way to explain it, not that's not better, but it's more
a different way.
Yeah, it would just be the integral of a to b of r of t dt over b minus a.
That is exactly what I'm about to write. Yes. No, you're a step ahead of me. Yeah. So what is this? This is about. No, that's awesome that you were leading me into saying that. 8.6 repeating. What would our units be? I forgot to put units in both of these.
Inches.
Inches. Yeah. Inches
Per hour.
and inches. Ooh, inches or inches per hour?
For average value, it's inches per hour.
Oh, is it?
Really?
I'm good.
Oh, okay. Well, because the top unit is inches. The bottom is what?
The hours, so it is inches per hour.
I don't know. What do we think?
Because you're basically dividing the inches to hours, and which is inches per hour, right?
It is inches per hour because it's the total change
I agree now.
divided by the number of hours, so it's the total
Oh.
change per hour,
Yeah.
or the average change per hour.
I agree. It should be inches per hour. I guess if we want to be correct, it's like that per hour. Perfect. Right at the edge of the screen. All right. So, and I'm going to just rewrite exactly what Rochelle just said. So it's the integral from a to b. I'm just generalizing here, our formula, of some function. I'm just going to call f. It could be g, it could be whatever. I'm just going to call f of x dx. And I need to divide that all by b minus a. And sometimes you don't want to write it like that. Maybe you're stressed on space, you don't have room for a giant fraction. You can rewrite it as pulling out this fraction. It can be 1 over b minus a out front. And then times that same integral from a to b of f of x dx. Both of them are the same, just in slightly different forms. I think we're all comfortable with those two different forms.
Can't forget your units.
And don't forget your units, yes. Yeah, I think the units are probably one of the most important parts on average value.
Wait, shouldn't it be f prime of x if we're doing average value of f? Yeah, it should be. It should be.
Change the r.
Because it was already.
Okay, let's go ahead and make this note then, Ben. We'll assume f is a rate.
Oh.
If we assume that f is a rate, then we're good. If f was a function of like position or something, then we'd have to do f prime. You're right.
So say it gives us an equation and it's not a rate. Like say like that r of t, it says that it's not a rate. Then we put it when we find the average value.
Yeah, you would, although I think at that point it turns into what you were thinking of, which is since we actually know those numbers, you're literally going to be doing a slope equation. Because finding average rate is really finding the secant line, the line that goes between point A and point B. That's the thing that we learned in like lesson 1-1 or whatever. That was like our first thing that we ever learned. It's just an average rate at that point. Yeah, but it's the same idea, which is you put a prime there. And then by taking the antiderivative of a prime in the definite integral, you're really saying f of b minus f of a, which is all divided by b minus a, which is literally that first equation that we ever learned in calculus was. Finding the secant slope. Does that ring some bells? Which is also from Algebra 1, yes. We're okay with this? So if they actually gave us f when it's not a rate, then it turns into average rate, which is a slope. Goes all the way back. Okay, so we talked about left sum, right sum, and midpoint sum yesterday. Let's talk about them again. So when I have a left sum, let's go ahead and assume we just have some data at the beginning. I don't know, some a and some b. We're trying to generalize this to make it nice and easy. And let's call this f of a, and we don't really need anything else. That will be our first rectangle. Do you remember the general shape that you draw for the left sum? It has a tail on the, I guess for you guys it would be
On the left?
on the left, yeah. So you do this shape. So you do chunk, 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 chunk.
Oh, you mean that? Okay.
Whenever you have a
It's like
table,
one of those things from
It makes sense.
Tetris.
Isn't it pointing right? Wait.
I guess the tail on the bottom, like
Okay, that was very confusing.
I'm thinking of this as like the little tail, the little snake tail.
Okay.
Or you can think of it as the handle of a weapon,
They don't
where the handle is on the left. Whatever is easiest for you to memorize, honestly, but it's that shape.
shape
Or how about
pointing
this?
right because the right.
You take all
Yeah.
two on the left side.
Oh yeah, so
Take all two on the left side.
the two
yeah,
values that we're
that's-
using are from the left side. Yeah, that's good. So what's happening here? Let's do the picture of the Riemann sum. So if I have, let's call that, I don't know, we don't actually need that one, but let's call that this is going to be A, so A is going to be right there. Let's say that B is going to be right here. It's going to be slightly increasing, and I don't know, there's probably some other point over here that we don't care about, but that's A and B. What does our rectangle look like? Does it look like that, or does it look like that? Is it that way, or is it that way? Does the height start at B, or does it start at A? It starts at A. Yep, go ahead and make it in your notes. Starts at A. Because it uses the leftmost point, because it's a left sum. And then, of course, we need our bar there and there. Oh,
Not very accurate.
I'm not very accurate?
No, this estimation. It's like probably a quarter of.
Oh, because the rectangles are so
Yeah,
giant?
that's insane.
It's just a to show you that it's a left sum, but yes, it probably is very inaccurate. We need,
just basically example to help us realize what left sum is.
yeah, but I can definitely see it's inefficient. Ben wants to have that n go to like 10,000 rectangles, so it's really accurate. Just program it, right, Ben? Right sum. We have a and b. Which height do you think we're going to be using between a and b?
B.
Yeah, we're going to do f of b. F of b. And let's go ahead and do the same thing. We'll have some random point there. We'll have a, we'll have b, a and b. We'll make a right there, b right there, some other point that we don't care about. All right, so which height are we going to be using? The height at a, height at b? Rochelle already gave it to us. You're going to be using that f of b. We're using the height at b, so it's going to be coming from the right point. Close enough.
Even on the point we don't care about.
You don't need the points that you don't care about. I'm just showing you one of those rectangles. We could have multiple of those rectangles if you want. And again, the general shape has two of those things on the right because it's a right sum. Let's talk about left sum and right sum a little bit more. Other things that we forgot to say is that this height right here is f of b on our graph. This height right here is f of a. Other things that we need on our graph. What is the formula for finding this area in terms of a, b, f of a? What is the formula here? Let's write it down.
It's b minus a times by f of a.
There it is, b minus a, and then we're going to multiply that by the height. So this is the base, and we're going to multiply that by the height, which is f of a. And again, if you need reminder cues, you can add it in your notes that this is the base, and this is the height. All right, what about this guy? What was our formula for finding the area of the rectangle?
Would it be the same thing?
Same thing, but with f of b, right? So it's b minus a, all of that times f of b. Done. All right, let's go to midpoint sum then. Any questions so far on left sum, right sum? We're just generalizing everything. It's very familiar from yesterday. Do we have things on the next page? No, we're done after this. We're just trying to generalize everything and introduce trapezoidal form. All right, so midpoint sum. So let's say we have a, b, and c. Which height are we going to be using between a, b, and c?
A and C.
Mm-hmm.
Oh, wait.
No.
B?
B.
B, yep, so we're going to have f of b. There it is. Good job.
I was thinking.
The midpoint sum is like it's the easiest and also the most accurate, I think.
Until we hit trapezoidal, yeah. It might sometimes even be better than trapezoidal. It depends on the type of function between 3 and 4.
Trapezoidal is just like slower.
What trapezoid look like?
Ooh, yeah, I'm getting excited for trapezoidal. Before we begin, let's go ahead and draw what's happening. So we need an A, B, and C. A, B, and C. A, B, and C. All right, give some random points. I'm just going to go chunk, 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 almost linear. I don't know what's going on. Which height are we doing? So you have 3 choices. You can go height like that. You can do height like that. You can do height like that. Which of those heights are we going to be using? Obviously, we're using f of b because we only have f of b there. So let me do that height and then make a rectangle. Chunk and chunk. Nope, a little bit diagonal there. There we go. I'm gonna call it good. All right. Yeah, and then we need a formula for our area here. So
It's C minus A times by F of B.
ooh, winds are picking up in Mammoth. Yep, you have it. C minus A times f of b. And before we move too fast, I'm going to analyze all of these things again. Also, the things that we use here. It kind of looks like a Tetris piece, I guess. That would be my way of seeing it. Or if anyone watched Teen Titans, it's the Teen Titan Tower.
Yeah,
It's just a T.
Or if your arrow, it's just a T. But I think of Teen Titans House because that's way
I think
cooler.
of Tetris because I played it yesterday on my flip phone. But it turns out you have to pay for it. Like, how did you get it?
What?
I don't know, I got it for free.
That's
It's
crazy.
like,
It's a flip phone, that's why.
yeah.
No, but when I had a flip phone, I got it for free. So
You
it was
have-
right there.
It had like a demo in the App Store, and it was actually pretty cool. And then it's like demo over, please pay. I don't know how much it was, but I'm sure it would be like $5 or more.
Yeah, so Teen Titans Tower, that's what it looks like. Now you guys know. Did you know that it was a T? I mean, you really need to know that
My
for
brother
calculus
watches
because
it.
you don't know the letter T. Does he watch the? It's a newer one that has like the cutesy
Oh, Teen Titans Go.
Teen Titans Go, probably. Or does he watch the original? If he watches the original,
He watches Teen Titans Go.
some people say that Teen Titans Go is better, but I personally
Is
prefer
it
the
like
classics.
Android versus Android Go? Or
I don't even
Windows
know what
versus
what is
Windows Go?
Android Go.
Maybe it's Windows Go.
I don't even know
Yeah, I
anything
think-
Go aside from Teen Titans.
I think Windows Go was like totally failed from like 2015 or something.
Oh, okay. It might be like that. I just know that some of my best friends in Mammoth really like Teen Titans Go over the original Teen Titans, but I just can't stand it. It's like
I don't have an opinion. I think they're
I don't like it.
both
the
bad.
humor for the newer one is more like cheesy, like fart jokes and stuff, and the older one was like very mature and
But
like
that
had
makes
these
sense for
deep
the
tones.
intended audience.
That's true.
10-year-olds.
Well, the old audience was better. That was me. I was the old audience.
Like 10-year-olds now these days are just all about farting jokes and
Fart jokes are amazing. I will put that out there.
They are.
I love fart jokes. If you make a fart joke, I will probably actually laugh.
Huh.
But it should be a good fart joke because I've heard a lot.
You need to get a good one and see it. Test out hypothesis.
All right, so for trapezoidal sum, we have A and B, F of A and F of B. So we have four things. It looks like a square, a Tetris square. We have a Tetris. It's not quite a Tetris L piece and L piece. It's a cut off Tetris L piece, L piece. Definitely that's a Tetris piece, and this could be a Tetris piece.
are we gonna use the whole all of them?
It's going to use all of them, yeah. So if I come over here, let's go ahead and draw a picture of what's going on. So I'm going to have A and B, A and B. Let's make some height, and a trapezoid. Does everyone know what a trapezoid looks like? I remember still learning about it in kindergarten, where my mom was my kindergarten teacher, so she told me, oh yeah, you have like this shape that, like, if you fell into as a human, then you can't get out because you can't climb up the walls unless they're rock hole things that there are not, and you're trapped in there. You're trapped in this shape. It says a trapezoid.
It says they're for trapping zoids, and you have to put pizza in them because the zoids like pizza.
Oh,
Who doesn't like pizza?
I mean seriously.
Anyway,
People that are allergic to dairy and gluten or something. I don't know.
Well, you might be trapped by
I've
the
had
trapezoid.
I've had no dairy
Oh,
pizza
yeah.
and it's still
So-
okay.
No, it's not okay.
Mostly the crust.
Arrow has spoken.
I think it's mostly the crust. It's mostly the crust and the sauce. Maybe even mostly the
And
crust.
the cheese is like
Oh,
absolutely
I
terrible.
love the crust. That's like my favorite.
Yeah,
part.
me too.
If you know what you're doing with the crust, it can be the best part of the pizza.
Yeah.
Yeah, but
What?
not like gluten-free, all fancy and weird.
And then
Gluten-free
that's what we
stuff.
did for
Right,
one of
which
the
is terrible.
Yeah.
Which goes with the dairy-free. Like dairy-free, gluten-free pizza is not worth
And how do we
So- So our trapezoid
it.
looks weird because our trapezoid fell over on its side. So our trapezoid would be, you'd be putting people in this direction, and then the zoids or whatever would be trapped in here, lopsided, and then they can't get out of the top, which is this direction.
Maybe it was parallel lines that the zoids like, and pizza.
Okay,
I think it was one parallel.
Can we have pizza one day?
You know what?
maybe.
No pizza.
But anyway,
Go for it.
Can we all shake our heads and say we see the trapezoid?
Yeah.
Do you remember the equation for a trapezoid?
No.
No.
Okay,
Well, isn't it? It's still half of a rectangle for that specific one.
half of a parallelogram, right? So if
this
I,
one's also half of a rectangle because it's it.
it actually
A rectangle
is
a
going to be half of a
triangle.
rectangle. You're right.
Oh.
Because if I copy this and paste it up here, it'll look like
Yeah.
that. And it'll be a perfect rectangle. But let's assume that we have this rectangle here where I have base 1, base 2, and a height that is at 90 degrees, which I will call height, H for height. What is our formula? I mean, I know that we could rederive it, and maybe we should rederive this. Do you guys remember the area of a parallelogram? Chung, 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 where you have base 1, base 2, and height?
But for a parallelogram, shouldn't base 1 and base 2 be the same?
They are the same. Yeah, I'm just copying the same thing so we can easily transition into one of them. What is the area of a parallelogram? Review from geometry. It's the easiest one. It's basically the same thing as a rectangle.
Base times height.
It's base times height. So this area here is base. It doesn't matter, base 1 or base 2 times height. It's that easy. What we can do with this trapezoid is we can combine it, and I still remember Ben doing this proof. Was it last year, 2 years ago? Some years ago, where Ben decided to flip this over and make this into a parallelogram, but I had 2 of them. Do we remember doing the proof for this for area, Rochelle, Arrow? You were both in different schools for geometry, so you might not have done this, you might not remember it, but this is the way of proving it. You have 2 trapezoids that you stick together and flip one upside down. So this and this are parallel. Those are also parallel. It's a parallelogram. The parallelogram has height, and it has this length here is base 1 plus base 2, yeah? Still remember this? Nope. But you can see that base 1 plus base 2 is the base now, yeah?
I think there's different ways that I found the height. Like,
The area of a parallelogram is just base times height, right? So the area of this guy should be base 1 plus base 2, base 1 plus base 2 times all of that times height, right? There's a problem though.
Over 2.
You multiply by 2 because you have 2 of these, so you need to divide that all by 2. And here's where the actual formula comes in. The actual formula is base 1 plus base 2 divided by, I don't know what I did there, divided by 2 times height. There is the formula for area. I always love rederiving it every single time with the parallelogram, Ben's parallelogram, I'll call it for the rest of my life, until he graduates maybe.
I don't remember doing that.
Oh, you're the one that proved it. You're the first person that I ever saw come up with it yourself. Just
Wait.
come up with.
so it's like a no
No,
formula.
I don't remember that.
Okay, well,
I mean, it's not.
I still remember. It brings a tear to
I
my eye.
certainly wasn't the first one that.
Don't remember.
Certainly wasn't the first one that came up with this.
I'll remember every first student that ever proves anything.
Wait, so is there another formula, or is that like,
That's the formula. That's it.
Okay.
I mean, you can shift this 2 around wherever you please. I can make it slightly longer, make it 2 there. I can do h over 2 instead of the 2 there. But generally, there it is. It's the average of the bases. That's another way of interpreting this thing right here. The average of the bases times the height. Anyway, this is base 1, this is base 2. On R, we're coming all the way back to calculus now. This length here is really the height of A. This height right here is f of A. This length right here is f of A. I will put that twice. This length right here is f of A. This height right here is f of B. Therefore, this other base length is f of B. Now we're just using our formula. We know the height. The height, you just take the distance between A and B, or B minus A, and then you multiply by the average of f of A and f of B, or just add them together and divide by 2. Here comes the formula. It's slightly bigger than the last ones, but here we go. The formula is, someone else do it for me. You have all the equipment in front of you, you just need to put it together.
So it's f of b times by f of a.
Careful, so it's adding them right here.
Oh, add.
So f of A, we're going to add that to f of B. It doesn't matter, you could have done f of B plus f of A. And then,
Divided by 2 times b minus a.
times B minus A. There it is. And again, if you don't like memorizing f of A plus f of B all divided by 2, I'll put a note here. This is really the average of f of A and f of B. Because the average, you add them up and divide by however many there were. So add them up, and there were 2 of them, so divide by 2. It's the average of those heights, the average of those bases, because it's kind of hard to see call them bases because it fell over and I have to look at it with my head to the left. We're almost done with today's notes. We have the formulas for all of them. I want to talk about what data is used for all of these tables. So I have my fancy pantsy. That's my eraser tool. Do I have a highlighter tool on here? I've always wondered. I don't think I do. Okay, I'm just going to circle areas. It's one drawback of using this program. What is not used for the left sum? Which of these cells here are not used for left sum? Review from yesterday.
One in the
F of B.
Corner? Oh, this corner. Okay. Cross it out. Cross it out in your notes. We don't use that one. Which one do we not use for a right sum?
The one under 8.
Yeah, you can kind of think of them as Tetris blocks sliding around, and you can't use that one unless you don't play Tetris and you're
wanted to play Tetris.
uncool like that.
I guess I have to pay.
Is it probably a chance?
What about a midpoint sum?
It's
Which ones do you not use?
It's the ones next to f of b.
That one,
Yeah.
that one,
And the
That
yes,
one.
That one.
and 2 other ones. Which other?
Oh, b.
You don't use B, and you don't use
That one.
that one. Yep.
What I see is like a
Alternate.
Yeah. It's a checkerboard. Exactly. You can play some chess or checkers. And finally, trapezoid sum. Which ones do you not use?
You use all of them.
You use all of them. And that's why it's the hardest, because it's the hardest formula and you use all of them. So use all of them.
Probably the most accurate.
And that's generally the reason why it is more accurate than midpoint sum. But sometimes midpoint sum can be more accurate. So use all.
But left and right are not accurate.
I don't know.
Left
why
and right
you
are pretty inaccurate, yeah.
Why would you use left and right sums when you have midpoint sum?
Because the AP test forces you to. They're like, use a left sum. You're like, but I don't want to. And then you have to. So that's what happens. That's it for the notes. Questions?
It's like forcing someone to use Windows XP when you have Linux.
What?
Which is still not, I mean, the fact that it's unsupported is the worst part. But Windows XP is still pretty nice.
I mean, yeah.
8.1 though, Windows
No,
8.1.
I had-
Really record all of our like tangents.
It totally does, yeah. And then years in the future when I'm sick, I'm like, go watch this video, and they're like, oh, I learned all this interesting stuff about Linux. Thanks, Ben.
It was like not related to what we were talking about.
That's what the Teen Towers Titan thing looked like.
Yeah, there we go.
All right. Any questions?
No.
All right, that concludes the lesson. Go ahead and write your summaries.